All right. So with that, we will now transition to our educational session on the state and future of USD animated characters. And I'll start with the background of the speakers we have today, and I'll let them take over the session. So we have Steve May, who's the CTO of Pixar Animation Studios and chair of Alliance for OpenUSD. So Steve May's tenure at Pixar Animation Studios spans more than 25 years, where he is currently Chief Technology Officer. In this role, he leads all technology at the studio, including software R&D, information systems, RenderMan, and the development of visual effect tools and processes for each film. He's also the founder and chair of the Alliance for OpenUSD, an open nonprofit organization dedicated to promoting the interoperability of 3D content through OpenUSD. Steve began his tenure at Pixar Animation Studios in 1998 as a technical director on Toy Story 2. For Pixar's next film, Monsters Inc., he helped pioneer the fur technology and overall look for the character Sullivan. He went on to work as a supervising technical director for Finding Nemo, Cars, Up, and Brave. Steve has a PhD in computer science and engineering from Ohio State University, where he was recognized as a distinguished alumnus by the College of Engineering. He's a member of the Academy of Motion Picture Arts and Sciences, serving on the executive committee of the animation branch. He's a member of the governing body of Disney Research Studios. He also serves on the technology committee for the Visual Effects Society and led the creation of the VES Emerging Technology Award. For the work on Up and Brave, he received 2 VES awards for outstanding animation in an animated feature motion picture. So welcome, Steve. And we also have another speaker who is Florian Zitzelsberger. He's the director of engineering at Pixar Animation Studios. And he helps guide the advancement of key technologies, including OpenUSD, Hydra, and the core of the proprietary Presto animation system. In his prior role, he helped develop Presto's high-performance execution engine. Over his 13 years at Pixar, Florian has been fortunate to collaborate with many of the amazingly talented engineers and artists who build the technologies integral to Pixar's storytelling. So welcome, Florian. So excited to have you both, and I'll give you, I'll make you co-host. So feel free to share your screen and start the session.
Really appreciate that introduction. I didn't know if you were going to read the whole bio. I would have made it shorter. little embarrassing, but thank you. And I also appreciate how organized you are. This is an impressive meeting, and we're very excited to be here. As Zeno said, I'm Steve May. I'm CTO of Pixar. I'm also the chair of the Alliance for OpenUSD. I'm very excited to talk to you all because we have a shared interest in characters. My bio has mentioned that I worked on Sullivan in Monsters Inc., and that was one of the first things I did here at the studio. So we have common interests, and that I'm joined by Florian, who has mentioned he's really he's director of engineering here, but he's responsible for a lot of our core technologies, and he also manages the team that's responsible for Universal Scene Description, or USD. So he's awesome. We want to kind of cover the basics and leave lots of time for Q&A. So we're going to try to get we're not sure how much everyone is familiar with USD or how characters are made at Pixar. So we want to cover the basics and then leave plenty of time for Q&A. So please don't be shy about asking questions at the end. I'm going to give a little update just on AOUSD. And before we talk about that, also just kind of get the basics of what USD is in case there's any confusion about AOUSD versus USD. Florian will kind of give some updates on the latest happenings with USD. I'll give a quick overview of characters at Pixar, kind of just the basics of how we think about designing and building them. And then Florian will kind of wrap things up by talking about our character technology and specifically what USD means in that context. And then hopefully we've got time for Q&A. Okay, so AOUSD. AOUSD stands for the Alliance for OpenUSD. And before we get to AOUSD, because again, I'm not sure how familiar everyone is, I just want to talk briefly about USD. USD stands for Universal Scene Description. We rebranded it as OpenUSD to align with Pixar's other open source projects like OpenSubdiv and OpenTimeline. So we rebranded it to be OpenUSD because, again, to be kind of aligned with our other open source projects, but also because it was annoying. If you Googled just USD, it takes you to websites about the US dollar, which is, the US dollar is important, but it's not that helpful for us. So we rebranded it. Pixar created USD. We open sourced it in 2016. It's based on decades of R&D here at Pixar and use and production of animated films for building. We've got very complex scenes in our films, and it's been from the ground up. It's been designed for the construction, interchange, collaboration, and simulation necessary for creating really massive and complex 3D worlds. And I think that generality is why it's become of interest, not just to people in the film industry, but to people outside of our industry as well. So then there's OpenUSD. So OpenUSD, I'm just to make sure that you understand the difference between these things because it gets a little confusing sometimes. OpenUSD refers to Pixar's open source project that implements USD. So that's the code base. It's the de facto definition of the standard, but it is defined by the code implementation only, which means that changes to the code can effectively change the standard. And that's why we created the Alliance for OpenUSD, which is really to formalize a standard that is independent of that code base. We realize that as the use of USD grows, we need a formal specification that is independent of our implementation so that users and companies can rely on USD and feel confident that they can build on USD going forward as a fundamental technology. So more formally, the Alliance for OpenUSD is an open nonprofit organization dedicated to fostering the standardization, development, evolution, and growth of OpenUSD. It was founded by 5 companies. It was founded by Pixar, Adobe, Autodesk, Apple, and NVIDIA. And it's pretty new. We just started it a little bit over a year ago. So far, we have a number of general members. These are the ones that I just grabbed this off the website a few days ago. I think it's a really interesting combination of companies from different industries that reflects the breadth of interest in USD. And the key thing here is that these members are all invested and directly contributing to the future of USD by actively participating in the Alliance. We made a lot of progress in the last year. The main thing is we built the structure and governance for the organization, of course, but we've also launched a number of working groups. And these working groups are focused on writing the specification for USD. And USD is sophisticated, so the specification writing is complicated. So we've broken the problem into smaller pieces, which is being worked on by these different groups. So we've got initially just three key working groups here. The core is concerned with defining the most fundamental pieces of USD, like the data format, the object models, the concepts related to scene assembly. And then we've got other groups like the geometry working group. They're writing the specification for fundamental geometry types, for example, subdivision surfaces. And likewise, the materials working group is doing the work to specify the way that surface materials are defined. And we, of course, expect many, many more future working groups to come. We've also formed interest groups. So in areas where we want more open discussions and maybe we're not quite sure what we want to standardize on yet, we built these environments for discussion about new areas or applications for USD. For example, I'll just mention one, the USD Emerging Geometry Group was formed to talk about new shape representations, like Gaussian splats. So in the case of splats, we kind of know they're an important thing, an emerging geometry type, but we don't really yet know if we have a quorum about how to standardize its specification in something like USD. So this group is to kind of gather experts and have those discussions. And you could imagine future interest groups related to things that this group would be interested with characters and avatars. Okay, so that's the basics of AOUSD, and I'm going to hand off to Florian to talk about the latest developments with the actual OpenUSD project.
Oh, thank you, Steve. And thanks again, everyone, for having us today. I'm going to give a quick update on some recent USD developments and some in-progress work as well. And I'm going to cherry pick and only kind of highlight some features that actually are relevant to character building in USD. So first off, we've added a new composition feature over the last year that's called relocates. So I'm not sure how familiar people are with USD, but if you are familiar with USD, the composition features are basically a language of like an algebra that you can use to kind of build up your scenes, to compose them together. And this feature in particular, relocates, allows users to specify edits to prims in the scene graph hierarchy purely via additional scene description instead of modifying the prims themselves. And this has actually been part of Pixar's internal animation tool called Presto since before USD even existed. And we've now brought it into USD to make it available to the community. And internally, we leverage relocates heavily for our character rigs. And I'm going to reference that in a little bit to explain how that works. Over the past year, we've also made a lot of performance improvements to USD Scale. Again, I'm going to talk about USD Scale in a little bit, but all of this feature work and performance work has landed in the 2408 release, and it mostly affects the performance of drawing USD Scale to Hydra Storm. But even if you're not using Hydra Storm, you might benefit from this work because we've addressed a bunch of performance bugs. In terms of in-progress work, we have the first phase of animation splines landing with USD 2408. And this initial phase includes serialization and basic evaluation support. But there's a lot of more integration work to do and API work as well. If you want to, you can take a look at the TS library as a preview of that API, but keep in mind that the API isn't stable. And in fact, we've already received some feedback, so we're kind of iterating on that API still. Then there's also another project in development that we call OpenExec, and that project refers to the open sourcing of our execution engine that's built into Presto, our proprietary animation system. And we'll be shipping OpenExec with the OpenUSD distribution, and it'll give you the ability to attach computations to USD scene objects so that those computations can provide computed values in addition to the values that are authored in the scene. And we're planning on sharing some technical details on OpenExec in an upcoming Academy Software Foundation USD working group meeting. So if you're interested, and the date is to be announced, we don't have that yet, but if you're interested, we'll keep you in the loop on that. Okay, so I'm going to hand it back to Steve to talk about characters at Pixar.
Thanks, Florian. Yeah, the anim splines in the OpenExec are really big components of the feature of USD that allow you to build character rigs, very sophisticated character rigs, and animate them. So those are two really big things. And before we get into some more of the technical details, we'll go back to Florian a little bit. I just want to kind of give some basics about characters and character construction at Pixar. So we do a pretty wide range of characters. I just grabbed a couple of samples. They tend to vary a lot in their form and complexity. For example, Elastigirl, she has these amazing abilities to stretch and change shapes, and Hank, the octopus on the bottom left from Finding Dory, interestingly, is like one of the most complicated and difficult characters to animate that we've ever done because the complexity of animating tentacles in a realistic way is a very challenging rigging and animation problem. Even characters, they may seem relatively simple at first glance, usually have high levels of secondary detail. So these characters, these are the motion characters from Inside Out. They have a level of complexity that you might not notice at first. So if you look kind of closely, they have this like inner energy that is represented by some pretty complex volumetric lighting effects and glows, and these dynamic particles that kind of float above the surface. You can see the anxiety kind of there in the foreground. You see these little bits. These are all animated kind of particle bits that add this extra dimension to the characters. And then last year, our film was Elemental. These were probably the most complicated characters that we've done to date. This shows Ember, the main character in the film, and she's made out of fire. And she's animated using 3D fluid simulations and rendered as a volume instead of using traditional geometric surfaces like we normally would. We had to simulate, store, and render dense 3D volumes for every frame of her animation. So it was a huge, huge effort. But most of our characters, and this is Riley from Inside Out 2, have a similar breakdown of elements. Each part of the character creation process uses a combination of proprietary and commercial software. That's our process at Pixar. We also have specialists as character artists that do each individual tasks. The artists we call character artists here do the modeling and rigging for each character, but we have other artists who separately do the hair, which is the groom is listed there, garments or props that the character interacts with. And for this presentation, we're going to focus on rigging. The rigging process is done in our proprietary animation system called Presto, which Florian mentioned, but we'll give some more details about. And this is a bit of an oversimplification, and you all will know this as experts in the space, but for us, rigging consists of 3 basic steps. The first step is fitting, which is essentially aligning the position of our base rig to fit our character. The body rig is set up like a skeleton, and in this example, we are fitting Riley's bones so that her joints are where we want them to be. And we work really closely with the animators on this part, because if we get the joint positions wrong, then the later steps will just add on to things that are fundamentally incorrect. The second step is weighting. As you're all likely familiar, weighting is the process of assigning the influence of simple deformations to each point of the modeled mesh. On the right is an example of weighting Riley's elbow bend. The elbow bend is a specific deformation. And so at Pixar, we rig our characters with very complex networks of relatively simple procedural deformations that impact a very, very, very local area. The deformers are all chained together to create very precise individual controls and high-level macros that combine a lot of deformers into a single control, like an eye blink or a foot roll. We don't use blend shapes in our rigs, really, except for fine-tuning the final silhouette shape of a pose. We call this sculpting, and we have a number of ways to do sculpting, but the most common is pose-based offset shaping. This gives us full control over the position of each individual point of our geometry in the context of a pose. So in this example, we can see that Riley is bending her elbow, and we can use the sculpting to define the bulge in her bicep when her elbow is bent. We do the sculpting on every pose and combination of poses we can control so that the characters deform exactly the way we want. Animators are especially particular about the silhouette profile of a character. We have a lot of other things we do too. Since we made Turning Red, we developed a new technique called profile movers. There's been some very nice papers published on this. It's really cool, but that's a whole talk in itself. And so just to give you an idea of the kind of complexity I'm talking about, I just want to show you these animation tests of the character Alberto from the movie Luca. Again, I want to emphasize the complexity of the rigs, because that will help you understand the way we think about rigging and how we think about USD. Like I said, Florian will get into that. Even though Alberto here is cartoony and has a pretty simple graphical design, he has a very complex rig. His rig has over 6,000 individual animation controls. And that doesn't even give the controls for when he turns into a sea monster in the film. So it kind of gives you an idea of the level of complexity we have. Okay, I will now hand it back to Florian to go into the technical details about how USD fits in with the way we build the characters.
Thank you, Steve. Okay, so I'm going to talk a little bit about character technologies that we use at Pixar, and there are 2 in particular that I wanted to highlight. We build Presto character rigs for essentially all of our characters, hero characters and secondary characters, and even the background characters. But we also heavily leverage USD scale for our crowds characters. Having said that, even crowds characters often begin live as a background character with a cheap Presto rig that we then bake down or simplify into a USD scale representation. Paul Kanyak, one of our own, actually gave a presentation at the MSF on that specific process. So if you're interested, you can dig up that recording and that might be worth reviewing. Okay, so what's Presto? So we've talked a bunch about it, but Presto is basically our proprietary digital content creation application. If you're familiar with Maya or Blender, on first glance, Presto looks kind of similar. In fact, this is what the UI looks like. It's very customizable and modular, so you can kind of move these panes around and kind of build your own workflows. In fact, we build different workflows for different departments in our pipeline. Many of the departments at the front end of our movie making pipelines use Presto. So, for example, character rigging, layout, and animation. But then we are also starting to push into departments that are at the back end of our pipeline, and we're kind of extending Presto to also work for lighting and rendering as well. In terms of character asset structure, I'm oversimplifying this, but we typically start with geometry and materials defined in USD layers. And then the deformers and the rig operators are authored in Menva files. And you can think of Menva as a superset of USD. Menva's value add is mostly, but not exclusively, for rigging features. And we've periodically moved features from Menva into USD. And we've seen that happen recently with relocates, as I mentioned earlier. So that's a feature that's existed in Menva for a long time, actually even before USD was a thing, and we've only now moved it into USD. Many of our rigs are very complicated, and in order to make them more introspectable, they're heavily componentized. So we leverage relocates and a symmetry feature in Menva to assemble the final rig from its components. So, for example, for a biped rig, you would assemble that from an arm rig, which is referenced twice and mirrored. So you have your left arm and your right arm, and then we do the same for the legs. And then you reference in torso, and then the face is typically like very customized to the character itself. Our Presto rigs are made of skeletal rig deformations that basically pose a invisible skeleton. We're posing typically around 100 joints. So we're talking about 200 transforms. And you would find around 1,000 rigging primitives kind of manipulating the skeleton. So logically, they're pretty complex, but cheap to evaluate. So as Steve mentioned, we use about 6,000 animation inputs. We call them AVARs at Pixar. Not all of them drive the skeleton, but a lot of them do. And then lastly, we have a control system that we use to pose that skeleton. And that control system can be dynamically switched. And it can even be switched within the same shot. So animators don't need to commit to one control system or another. They can dynamically switch between them. Then we apply skin deformations to basically pose the skin mesh around the skeleton. And as an input to this deformation chain, we get the post skeleton as well as the skeleton at rest. And then again, some of those roughly 6,000 animation controls are used for posing. And with this stage of the rig, we pose around 100,000 points, so like mesh points, vertices. And we use around 1,000 deforming primitives for that, and lots of per point weighting, as Steve showed earlier. And so really, we're posing a lot of data at this stage. So relatively, this part of the rig is less complex, but it's posing a lot of data. Skin deformations are typically authored as linear deformation chains. The execution system exposes the ability to pose parallel chains, but character TDs sometimes take advantage of that, but typically author linear chains of deformers. And then regardless of how deformation chains are authored, the execution engine is smart enough to tease apart the per point dependencies and then automatically applies deformations in parallel. Our characters sometimes take advantage of deforming lower resolution geometry, and then we project those transformations onto higher resolution geometry. And then when we take advantage of that, we can then also additionally deform the higher resolution geometry after. So the projection of lower resolution geometry onto higher resolution geometry in itself is really just a deformation step. Underpinning all of this is the Presto execution system, and that system is comprised of essentially an execution engine, an object model for rigging that's implemented on top of that execution engine, and then a library of deformers that are implemented on top of this object model. With OpenExec, our immediate goal is to bring the execution engine over to USD, and we'll also bring along some of the building blocks for implementing a rigging object model, but we are not immediately planning on making Pixar's own rigging object model or its library of deformers part of USD. And then lastly, I wanted to note that our rigs have undergone a bunch of iterations over the years. And what we show today is basically capturing the state of the world today. But in the past, for example, our rigs had skeletal deformations and skin deformations heavily interleaved. And Presto's execution engine as a general purpose computation engine decouples the rigging object model from the execution engine. So this allows us to actually make changes to how we rig our characters without having to change the underlying engine. And similarly, if we want to advance the engine architecture, we do not have to change our character rigs to support that. Okay, moving on to the second technology called USD Scale. USD Scale is a set of schemas that ships with USD, and it enables you to express skeletally skin meshes and joint animations. It gives you the ability to encode skeletons and blend shapes for linear blend skinning. And then blend shapes are static in the sense that they define a static final shape, but you can obviously animate to blend between different shapes. And these blend shapes are also authored as deltas on top of the mesh. And then we also ship USD Scale basically with an evaluator that basically poses the rig. Poses the skeleton, and so you don't have to write your own evaluator with USD Scale. At Pixar, we mainly use USD Scale for crowds. So this technology is optimized for scalability rather than sparsity. So it scales quite well with massive crowds, like in this stadium scene right here. But that's not to say that USD Scale can't be used or doesn't work for sparse use cases. It's just not how we exercise it within Pixar day to day. For example, USD Scale actually has some cool instancing abilities. So you can have like a skeleton that's a prototype and then apply per instance animations without having to deduplicate the instances. Cool, and here's a stadium scene in a shot from Turning Red. So we're leveraging USD Scale for all these crowd characters, and then the hero characters are using full Presto rigs. Okay, so we also wanted to kind of take a step back and share some additional thoughts on USD Scale and sort of reflecting on some observations we have and also maybe thinking about future direction a little bit. So there is no built-in animation blending in USD Scale. So even though it has this pose evaluator built in, it doesn't have the ability to dynamically blend between animations. In fact, there currently is no way to actually express multiple animations bound to a single skeleton. So supporting something like that in USD Scale is actually kind of interesting to us. And we're also thinking about generalizing that. USD has this feature called value clips that let you express animation. So rather than just allowing you to do multiple animation on USD Scale, it would be cool to actually add that to value clips and leverage them with USD Scale. As I mentioned, that we are bringing animation splines into USD. And so we're already kind of thinking about the cool ways we could leverage those with USD Scale. So for example, we're thinking we could use animation splines to sparsely author animation for transform operations to pose the individual bones. And then lastly, we have this schema called USD Physics, which is capable of expressing character dynamics. So for example, moving hair or cloth. But USD Scale and USD Physics are not tightly integrated, and you'd be on the hook for bringing your own simulator. So in terms of what you can do with USD physics is express the dynamics, but you would still have to evaluate them yourself and then author the simulated results back to the bones, for example. But with OpenExec sort of on the horizon, we're thinking about whether that might open the door for some tighter integration of computed behavior. And so something like running that computation, kind of that simulation on the fly, and then applying the results to the bones, that could be kind of cool. In all of this, we're kind of looking to find people to collaborate with, and would love to collaborate with any and all of you. The different ways of doing that is to the QR code leads you there, which is a GitHub repository called OpenUSD proposals, where folks can publish project proposals and iterate on them with us in the community. And then this is the main link to the OpenUSD code repository. If you're interested, we have an issue tracker there where you can file bugs, or you can submit a pull request if you have any bug fixes that you'd like to contribute back. And then we have our main community discussion board hosted at the AO USD. And this is the primary place to ask questions and get guidance from the OpenUSD community at large. So if you're interested in engaging, we'd love to find you there. And then lastly, the ultimate form of collaborating with us. We're hiring in the USD team and the team that deals with Hydra and OpenExec. So if you or anyone you know wants to help us build those cool technologies, here's the link. Please apply. Would love to work with you. And then that's it from us. So we kind of want to open the floor to any questions. And I'm going to stop sharing the slides.
Yeah, great presentation. Thank you, Steve and Florian. A lot of insights today about USD. So yeah, like you mentioned, I think there's a lot of questions around the differences between AOUSD, OpenUSD, and USD and how it's used. So thank you for sharing insights today. So anyone who has questions, yeah, please raise your hand through Zoom, or you can also mention that in the chat. Yeah, Hideaki, go for it.
Hi, this is Hideaki from BRM Consortium. So thank you for the great presentation. And I have a few questions. So first question is, I was interested by the non-destruct feature of the USD you mentioned in the earlier slide. So what are some of the example use cases for that non-destructive feature?
You want me to take that, Steve?
Yeah, go ahead, or you go first.
So we leverage that heavily in the way that we make movies in our pipeline, where we have like multiple departments kind of working on the same assets potentially at the same time. And we don't want people to step on each other's toes. So what we do is kind of express in our layer hierarchy, for example, kind of the stages of the pipeline. And as the asset moves through our pipeline, any department later on never erases any edits that have been made by an earlier department. They just author on top of it. That authoring could be overriding an opinion that someone else expressed further upstream in the pipeline. But we always want to be able to rewind to that stage. Does that make sense?
I see. So is that similar to the Git?
That's an interesting comparison. Yeah, I think conceptually similar, in implementation very different, but yeah.
I think, and it's dynamic, right? So big part of what USD does is it takes all these layers and composes them together and to give you a view of the scene that can change depending on the user or the conditions that are happening. It is very much like Photoshop, where you've got layers of images that are composited on top of each other. Only USD can do that with any kind of data. And it has some really, in addition to allowing many people to work on a scene at the same time and not mess each other up, it has some really powerful capabilities. I remember one of the first things we did on Brave that really leveraged this is we have a horse as one of the important characters in the film, and an animator needed to do some special animation for just a couple of shots, right? So instead of going back and changing the horse asset, we actually just added a new rigging layer inside the shots. And so that kind of very unique feature was only in those shots. So it didn't change anything else about the base character, which is really, really powerful, because you can kind of make these local changes. It might be kind of weird. Maybe only one animator wants to do it this way, but they can make that change and they can have that local composition in their shot while they're working. But it doesn't change the rig in any of the other shots that have already been animated. So it's super powerful.
I see. So I think that is also related to my next question. So I was also interested with the dynamically switchable rigs. So the use cases for that feature is so that special effect that can happen in single scene or something like that. And on the other scenes, animators don't have to deal with a bunch of parameters that is not relevant. Is that what the dynamically switchable rigs are for?
I think you're referencing when I said that the control systems are switchable for that we use to pose the skeleton. Like, sorry, let me confirm that. Is that what you're talking about?
I think that is really. I think it was in the slide where you explained about the rigs and which are switchable dynamically. Mm-hmm. So I think that is correct. Yeah.
Yeah. So we don't actually switch the rig per se. We just switch the control system that poses the skeleton, and you can think of stuff like inverse kinematic versus forward kinematic, and like how you want to manipulate, how you want to interact and manipulate with the character on screen, kind of direct manipulation behaviors, and so you can dynamically kind of switch between them. And it's a plugin system, so we can kind of build arbitrary control systems to interact with the rigs, and they're ephemeral in a sense.
See, and is that feature included in the OpenUSD, or is it just a proprietary USD?
Yeah, it's proprietary. It's specific to Presto. Mm-hmm.
I see. Thank you very much.
Mm-hmm.
Yeah, I had one quick question on the USD. Like, when I was seeing the last GDC, right? So Epic Games gave a presentation where they showed an example where you can do apparels in Marvelous Designer, and then you can bring it to Unreal Engine, and in real time you can change it in Unreal Engine to swap the Fortnite's character outfit. So that transfer of asset data from Marvelous Designer was exported as a USD. So any insights into why it was decided to use USD there? And because traditionally I've seen people using FBX and GLTF, and this was the first time I saw USD used for a real-time use case. So any thoughts on why they chose to use USD there?
I'm going to let Florian jump in here too, but I can't say specifically why they did at Marvelous, because I don't know firsthand why they did. We are seeing definitely an uptick in interest in USD amongst in kind of the more the gaming development arena, and I think that just it shows that almost all of the DCCs that we use within visual effects now support USD more fully. And I think there's overlap in some of those DCCs also with game development. So you're also seeing USD make its way into gaming as well. And I think it's just it kind of shows that there's a lot of overlap between the spaces of filmmaking and between gaming, and you're just kind of seeing recognition that the things that USD does well for us also can make sense for real time or immersive content as well. There's probably more work that we would have to do because Pixar doesn't think about it as much. But when we're animating our characters, the animators are animating them as real-time characters. So it's different because our final product is a recorded film. But while we're working, we also want to think of these things working well in real time as well. So I just think there's a lot of opportunity to leverage, especially the complexity management that USD has. If you want to build large, virtual worlds, potentially with lots of users and very, very complex systems, USD is particularly well suited to that.
Yeah. And yeah, Florian, do you have any add-on to that?
Yeah, I also don't know why they're using USD, but compared to the other formats that you mentioned, USD is a little bit richer in what you can express with it. So I can only hypothesize, but you don't need to export or like if you save out the USD, you're not losing anything. Like you can carry that richness through your pipeline, and in this case, just into the game engine. You don't have to bake it down and export it, and you save that extra step, right? And conversely, like I think the game engine use case maybe is a little bit different because bringing it into Fortnite, you sort of like consuming that asset. But if you were to actually edit it in Fortnite, right, you want to be able to round trip that edit back into Marvelous Designer. So you want to carry those edits forward. And so USD has that capability, whereas the other two formats are, well, maybe not to the full extent that USD does. Yeah.
Sure. Yeah, thank you. Thank you for that information. And just a follow-up question there, like because like in the open source community, like there are ways you can author, for example, let's say like changes in the mesh or addition of skeletons. Now, from the presentation, you showed two ways to author skeletons in the USD system. One is through USD Scale, another through Presto. Now, like what level of support is available, let's say if we use open source tools like Blender, where we want to author other custom rigs that can work with characters and still use it as USD.
So I don't know what Blender's feature set for USD scale is. So I can't speak to Blender in particular, but out of the stuff that we showed you, USD scale is mature and out there, ships as part of USD, and OpenExec, which is sort of underpinning the Presto characters, is sort of a glimpse into the future of how you might be able to build more complex characters, in the future once that system lands. So USD scale is the only option currently. To what extent Blender it supports USD scale, I don't know. I'm sorry, but I can figure that out and get back to you for an answer.
Sure. Yeah, thank you. And any other questions from other members?
Hello.
Yes, Joe, go for it.
Hi. I think it's fantastic to see that and the approach of more or less standardizable sets of data to animate and produce frames. And the next step is understanding that this device, avatar of some scale that some author prepares, is working in some environment that's more or less a standardized or standardizable environment, that a more or less standardizable character is operating in. And that real-time aspect of interactive with the user and with other users in that environment. And the runtime. Hey, thank you. Very nice. I really appreciate seeing that. And X3D H-Anim. Oops.
We agree.
Right. Cool. I think yeah, we are running out of time. So can we take 5 additional minutes in case we want to go over more questions?
It's fine with me.
All right. Any other questions from any of the other members?
Yeah, I have a couple quick questions. How do you envision using USD for metaverse avatars, and what layers would be incorporated into OpenUSD for that purpose? And additionally, what work would be required to adopt OpenUSD at scale in metaverse platforms? Or is there a lot of work to be done? Is this kind of in its infancy, or is it ready to go?
A great question. So USD is sort of production proven for VFX. We've used it for a long time. It's used in some other domains in terms of like avatars for the metaverse. We're kind of looking at you to like help us figure that out, right? Like, what do you need? What works well? What doesn't work well? And like, how can we help you get there? Sorry, maybe not super satisfying, but that's kind of like our philosophy. Steve, do you want to add anything to that?
Yeah, I mean, I was going to say that the USD works at a very fundamental level. And as Florian said, Pixar's, we've explored the space for the kinds of animated characters we have in our films, but we have not specifically explored the space for avatars. And I think there are probably different requirements. But USD is very, very general purpose in terms of what you can describe, and you can customize it. It's been designed kind of from the ground up to be customizable, so you can define new schemas and new features that you want to have for something that's unique and different than what we've already done, which is why I think we're seeing acceptance and growth in USD in areas like AEC, architecture, engineering, construction, things we never thought of, for doing digital twins of manufacturing plants, et cetera, because it is so customizable for the problem you're trying to solve. And I think it's particularly well suited for, I guess, we all know metaverse is a pretty broad term, but this idea of like having interconnected sets of assets that are maybe not even all residing in the same servers or data centers. USD is kind of intrinsically built to kind of manage that kind of complexity, where you could even have layers that are being composed together for a given asset, but those layers actually come from different locations. So there's some really powerful opportunities there.
That is
Thank
a
you
great
very much.
look of it, in that it looks like a database where that data can be anywhere, as long as it has a clearly, strongly typed data, can be referenced from anywhere and sent to anywhere.
Yeah, that's an interesting take. Actually, you're not far off. That USD is kind of like a database plus a framework to kind of assemble the data, right? This like composition logic that brings all the data together. But yeah, it's built to be generic.
Yeah, we should mention too.
Mm-hmm.
Sorry, go ahead.
I was going to say, with the connections, the GLTF, and looking up to whatever Cronus hierarchy.
So I wasn't sure. Are we asking a question there, or was that just a...
No, I'm fine. It was just the idea of the strongly typed data and the functionality, how the functionality is handled in the USD. It shows a strong data typing, and if the contents can be manipulated in real time to produce real-time interactions, then that will be the object sooner or later. And but the GLTF for the web, for this to be implemented as a web browser, kind of not even an appliance, a freestanding web browser run by USD.
Yeah, the AOUSD has a liaison relationship with Kronos, because I think this is one of the active areas of discussion. How do these different formats fit together? What functionality do they complement each other with? Should there be overlap? Those are active discussions. We also think that USD could be a very high performance, lightweight format as well. We have definitely focused on managing the kind of complexity we need for our films, but we also are very optimistic about how efficient it can be, because we've explored that quite a bit internally at Pixar.
We have a question from Rosalind, so let's keep this as the last question, and we'll end the recording after some final updates, and then we can move to a few minutes of work. But go for it, Rosalind.
Awesome, thank you. Can you hear me?
Yes.
Sorry, I'm going to turn on my camera. I'm with my avatar today. Awesome presentation. Thank you so much for coming to this group, and I'm really lucky that I decided to join on this day because I had no idea you guys are presenting. But so you had me thinking there for a moment when you said that the assets can reside at different areas, different servers, whatever you want to call it. So we at the Digital Asset Management Group right now, we're focusing on, we're working with OMA3, which is the Open Metaverse Alliance for Web3, focused particularly on blockchain. So right now at the Digital Asset Management Group at MSF, we are exploring NFT metadata and what requirements for that would be. And part of it, why we wanted to talk to Hideaki about basically about what would be the requirements for avatars metadata to be considered to be NFT metadata. So as you were talking about these various servers, I was wondering, have you guys considered at all at OpenUSD integrating NFTs, whether it's for tracking the creator that created the file? So is as this file format gets adopted for video games and open metaverses, and then we're able to log into a metaverse with a digital wallet, right? And then we start transacting with all these files. Some creator created it, and I'm just thinking out loud, it would be awesome to have some kind of metadata tracking within the USD file format itself. So at the moment of creation, that's attached to some blockchain. So yeah, that was my question. What have you guys thought about that at all in any way?
Oh, it's a great observation and a great question. And it has come up. I'll let Florian follow me, but it has come up. We have not actually explored it in any depth, but I think you're right on. Florian, do you have anything you would add to that?
I think, I was going to say it doesn't really overlap with like our usage of USD internal to Pixar, but it's an interesting thought. And you could imagine building a USD schema that encodes that type of metadata, and it'd be cool to see like some sort of proposal or something of what you're thinking about, and also maybe bring your USD.
Awesome.
And it might not has mattered too much immediately to Pixar, but you can imagine if the future, and especially we're part of a bigger company called Disney, that certainly would probably be interested in like digital collectibles and being able to transfer characters or collectibles from one platform to another and have ownership and that sort of thing. So it makes a lot of sense. It'd be exciting.
Cool. Awesome. Thank you so much. And again, thank you. Awesome presentation. You guys do some amazing work. The best.
GLGF is made for that.
Right. Thank you, Ruslan. So yeah, let's quickly transition to some updates, and then we can